Welcome back. In this lesson, you're going to look at deleting a node from a linked list. We'll visualize what that looks like, and then we'll write a Python procedure to do it. As before, we'll use a 2D array to set out the nodes of the linked list. We'll see how to use pointers to delete a node. It's very simple, and then we'll write a procedure. So here's the typical visualization of a linked list that we've looked at many times. It's embedded into a 8 part 2D array, and it just goes A, B, C, D, E. The header points to 0 and the free pointer points to 5. We won't need the free pointer for this work today. So the first thing we've got to do is traverse through the list to find the node that we want to delete. There's two ways we could specify that, and I think you'll remember that Python's got both types of delete. One is to specify the data value, and the other is to specify which number item in the list you want. So you might say delete D, or you might say delete item number 4, or something like that. In this instance, D, we're going to look for D. And we have to find the node that points to D, and we've got to find what D points to. So we've got to look at more than one node at the same time, which is different from append or insert. Other than that, it's actually quite a simple process. All we have to do is to take the pointer from the node we want to delete and copy it up to the previous node. You've then overwritten the pointer to D, and next time the computer goes through the linked list, it simply won't go to the node with D in it. There's no need to wipe it or overwrite it. That's just extra work and it's not necessary. There's no pointer to it, so when the computer goes through the linked list, it will just skip directly from C to E. And that's that. That's all you have to do to delete an item from a linked list. So first you can have a quick go visualizing it. Draw the array that we started with and show how you would change it to make it skip over C instead of D. If you want to quickly do that, pause the video. I'll show you the answer on the next screen. So there's the answer. There's no pointer to node C. It goes from 1 to A to B to D to E, and C just doesn't exist as far as the computer is concerned. You don't have to wipe it out, it's just gone. So that's it. It's pretty straightforward. So if you want to try and make this program on your own, I will show you in a minute, but if you'd like to try it without help, this would be a good point to pause the video, open the linked list program that you made before, extend the menu so that it includes an option D for delete, and create a procedure that will carry that out. You can either make it delete a numbered value or a value identified by the data. So whichever one you want to delete a node from the list. So here's the main program. You'd also obviously extend the menu and just add these 3 lines. If they choose option D from the menu, we get a value, and then we're going to delete that data from the main program. As I say, you could also ask them to enter an integer and count through until you get to that sequence in the linked list and delete that one. Choose one or the other and write whichever one you like, and then for extension work do the other one. So now you've got to write the delete procedure. It's only got to do 2 things. One is count through the linked list, traverse the linked list until you get to just before the one you want to delete, and then copy the pointer from that back to the current node. And that's literally all you have to do. This is the old traverse procedure, and we've used something very similar in the traverse, in the insert and in the append procedures. So you should be very familiar with that. It starts at the header and follows the pointers down. Now I'm going to have to change it. Can you think how it needs to be changed? I'll say in a moment. If you want to pause, write down what you think is the right answer. So the answer is I've got to change it so that I can see the next node as well as the current node. So they've both got to be kind of in play at the same time. I'll change it like this. So I start at the header. The pointer is the second value of the node. And as long as it's not pointing to none, I'm going to continue through the list. So I'll traverse the whole list. I'll make some changes in a minute, but for now I'm going to traverse the whole list. And the next node is whatever the current pointer is pointing at. And then to move on, we set the current node to be equal to the next node and reset the pointer. So there's one extra line and I've got the next node, and then I change the current node to the next node, and that makes me move on through the list. So it's almost the same as before, but I've got two nodes in play, next node and node. Now what I've got to do is check if the next node is holding the values that I'm looking for, because if it is, I've got to delete it using the method that we've just learned. So I'm traversing the whole list, setting the next node, looking at the next node, and if the value in the next node is the one I'm looking for, I've got to do that overwriting the pointers thing. What you could do is try and write this on paper and see if you get it right, and then if you do have it right, you can try it out in Python. So I'll just show you what the next line is. What happens if I find the value that I want to delete? The current pointer becomes the next node's pointer. So I basically overwrite the current node's pointer with the next node's pointer. And I also return to the main program because I've done my delete. I could do without return. That would make my delete procedure work slightly differently. Can you think how? So have a little think about that. That's another challenge. You'll see the answer in a moment. So basically that's the complete procedure, the complete delete procedure. I start at the header, I go through the list, and each time I set the next node, I check what the next node is going to be, and if it's got the value I'm looking for, I copy its pointer back into the current node and return to the main program. I asked you to think about what would happen if return wasn't there. Basically, it would delete every single node that had that value. So, for example, if the letter D came up several times in the linked list, it would delete them all. Which is one way that delete can work. It depends which you want. So you can write either sort of software, make either procedure. So that's it. It's pretty straightforward, isn't it? So there's three things for you to do. One is to simply copy the procedure shown here. As always, there's two ways you can do that. One is to run the video and have Python open on the screen at the same time and just build it up. That's absolutely fine to do that as you're learning. Another thing you can try instead of or after that is just do it from memory. And then you can amend and improve it. You can make a new version where we identify the delete node by position. Delete the third node in the list instead of delete D or whatever. And that's just an alternative. You could create two procedures that work the two different ways. And an improvement that you can make is to add validation checks, because there are some inputs that wouldn't work properly. For example, if the person asks to delete X from the list and there isn't an X in the list, how are you going to handle that? And secondly, if they give a number value that's larger than the list, like they say delete the 100th value in the list and your list isn't that long, or they give another value like -6 or something that just doesn't make sense. So try and catch with validation all the various bad inputs that the user might enter. So that's it. That's the last bit of coding that we'll do. Python using the 2D array method. There's one final presentation, and that's all about object-oriented programming. You might like to try that in advance, but there'll be a video coming up about it in the next hour, so it might be there already by the time you read this. So I'll see you in the next video, and don't forget to send me your samples of code so I can see how you're getting on. Bye for now.